Today we're going to be talking about antennas. We're going to cover a lot of the basics, the different types of antennas, how to read an antenna pattern plot, and especially how to visualize antenna coverage in 3 dimensions. So we're going to be talking about 5 different types of antennas today, starting with the basic stick omnidirectional antenna, moving to another type of omnidirectional antenna called a squint or a down tilt antenna, which is pretty interesting. And then we have 3 different types of panel or sector, or sometimes indoors they're called patch antennas, that are used for different applications outdoors. But before we get to that, I want to first talk to you about gain, as this is one of the most important subjects around antennas that can be difficult for newcomers to understand. So gain is a basic property of an antenna, and the purpose of an antenna is to really focus and direct the RF energy that is being emitted by the radio in a desired direction with a desired pattern or shape. And so this is what we call gain. Gain is often misunderstood as somehow increasing the power that is coming out of the radio. And this is absolutely not the case. A good way to sort of visualize what I'm talking about is if we take, a lot of introductory RF classes will talk about this construct called the isotropic radiator, which is a imaginary sphere that is meant to describe a perfect antenna that radiates uniformly in all directions. So the reason we start with the isotropic radiator is it makes it actually a lot easier to understand this concept of focusing as opposed to creating power. So imagine that the volume of this balloon is the energy that is being emitted by the radio. Now, we said that a isotropic radiator doesn't exist in real life. So what an antenna does is shape the balloon in one direction or another, or maybe bend it in the long way. So specifically, if we talk about a stick omnidirectional antenna, such as the rubber duck antenna that you may be familiar with, or this type of antenna, that's going to cause a deforming of the pattern. In other words, we're going to compress the top and the bottom of the sphere, and it's going to cause the sides to expand left and right. And the total energy is still constant, but we've now focused it, in this case, in a 360-degree pattern all the way around the antenna. Another way to think of this is that we have increased the horizontal coverage at the expense of the vertical coverage. Okay? Now, if we're talking about a panel antenna, in this case, we're going to be, imagine that we're squeezing the balloon from the back, and we're causing it to spread further in a single direction as opposed to in all directions, and it's going to be very narrow at the sort of throat where it leaves the antenna, and then it's going to widen as it goes out. So in both cases, you can see that the energy is constant. It's simply being focused in a desired direction. And so whenever we talk about the gain of an antenna, it's critically important that we also talk about the direction of that gain in both the horizontal and the vertical planes.